Hello, this is Brother Cromer from the Math Department at BYU Idaho, and we'll be covering now Lesson 10, which is dealing with inference for one mean sigma known, or standard population standard deviation known, and we'll be focusing in on confidence intervals. Now, first of all, I want to review a couple of issues. The first one is dealing with a parameter and a statistic, or parameter versus a statistic. So a parameter is a measure of the population that's typically unknown, but we like to estimate it. For instance, we have the population mean mu and the population standard deviation sigma. Now, a statistic is a measure from the sample. So a statistic is used to measure the unknown parameter. And so in this case, the statistic can be, for instance, x bar, which is our sample mean, and s, which is our sample standard deviation. So a statistic estimates a parameter, and x bar, for instance, estimates mu, which is dealing with means, and s estimates sigma, which is dealing with standard deviations. Okay. The next item I want to review is sampling distribution. So a sampling distribution, or the distribution of sample means, has many sample means from many possible samples. However, due to time and money, one cannot take multiple samples or sample the whole population, so we infer based on typically one sample. So the statistic, or the sample mean, can be anywhere in the sampling distribution. This is also called the point estimate as well. So say, for instance, this is our sampling distribution, and mu represents our true population mean. We get an x bar here, here, or here. So there is some possible sampling error when it comes to getting a sample mean and all these different possibilities. Okay. Now, for instance, if we have something close to the population mean, our x bar, then we'd be pretty good. But if we have something maybe out here, then it might be concerning. Okay. However, it's not too terribly bad, because what we have here is a confidence interval. We can actually take a confidence interval and see and have a high level of confidence that our confidence interval contains the true mean. And what our confidence interval is a confidence interval for an unknown parameter, and it consists of an interval of numbers. And the general formula for a confidence interval is taking your point estimate plus or minus the margin of error, or that sampling error. For instance, with the general election back in 2012, President Obama versus Mitt Romney, there were pre-election polls that occurred, or that took place before the general election. And for instance, there may have been one poll that showed that that 49% of all Americans would vote for Obama, with a margin of error plus or minus 4%. So what that means is that we are so many, or X% confident that the true proportion of people voting for Obama will be between, in this case, 45 and 53%. So generally speaking, what does that mean for confidence intervals? What that means is that we are X% confident. I'll talk about what X is in just a moment. We're X% confident that the true value is between the lower limit or lower bound, or the upper limit or upper bound. So we can have a sample mean somewhere here, but if we have a margin of error, our goal is to be able to contain the true mean with a high level of confidence. Okay. So now let's get into the formula for the confidence interval. So the 1 minus alpha times 100% confidence interval formula is x bar, which is our point estimate, plus or minus, and everything to the right of the plus or minus sign is what's called the margin of error, which is listed down here. Okay. Where z star is what's called the critical value. Okay, sigma is called the population standard deviation, and n is our sample size. Okay, now a couple of things you need to know is, first of all, the order of operations suggests that we need to do everything to the right of the plus or minus sign. We multiply and divide first, so we calculate the margin of error first, and then we add and subtract from the sample mean to get our two values, our lower bound and our upper bound. The second item of note is that dealing with what the z critical value is. What are those numbers? Well, there's three levels of confidence that typically most industries deal with. One is a 90% level of confidence, 95, and 99. Associated with it is the level, if you remember alpha, that's the level of significance. And from lesson 9, we talked about hypothesis testing. So for a two-sided test, for hypothesis testing, if alpha is equal to 0.10, or level of significance is equal to 0.10, level of confidence would be 90%. For level of significance being 0.05, level of confidence is 95%, and the level of significance is 0.01, the level of confidence is 99%. So with our critical values that are associated with these confidence interval levels of confidence, it's 1.645, 1.96, and 2.58. Now, where do you think we might get these numbers, or how we got those numbers? Well, if we go to the applet, and I need to get the applet here. If we get to the applet, I need to activate all the plugins here. If we go to the applet, we will determine how we can get that. Now, if we shade the center here, and in the top I type in 0.9 for 90% and press enter, we get a critical value of 1.645. Okay, and that matches what we have here on this slide here. Now, if we type in 95 or 0.95 for 95% confidence interval, we get a critical value of 1.96. And if we type in 0.99, we get a critical value of 2.576. And those match, with rounding here in the last one, those match these numbers here. Okay, so now what I'd like to do is I'd like to go into an example of how to deal with this confidence interval. Okay, so here's the formula for the confidence interval. Let's go through a problem. Based on a historic data obtained from Brother Scott Bergstrom, the grade point average of students at BYU Idaho is known to have a population standard deviation of 0.68. We want to create a confidence interval for the true mean GPA for last semester. So a total of 24 people were surveyed and asked to report their GPA from last semester. The mean of the GPAs in the sample was computed to be 3.263. So the first question is, what is the point estimate of the true mean GPA? Well, the point estimate is x bar, which is our sample mean, and the mean from the sample is 3.263. Okay, so then what is the margin of error when doing a 95% confidence interval? So here we're going to solve everything to the right of the plus or minus sign. So if we're doing a 95% confidence interval, Z critical value is 1.96 times the standard deviation, which is 0.68, divided by the square root of our sample size 24. So we get a margin of error of 0.27. So then the next question I have is, find the 95% confidence interval for the true mean GPA. Also interpret it. I'll ask you to interpret it as well. So here is how we calculate it, where we take 3.263 plus or minus the margin of error here to get two numbers, the lower bound and the upper bound. Now remember, we have to multiply and divide first to the right of the plus or minus sign before we add and subtract from the mean. And so we get two numbers, the lower bound and the upper bound, of 2.99 and 3.54. So then how do we interpret that? Well, how we interpret that is that we say that we are 95% confident that the true mean GPA is between 2.99 and 3.54. So now I want you to stop the video and calculate and interpret the 99% confidence interval for the true mean GPA. Okay, so now how we calculate that, the only thing that changes between this one and this one is the critical value. So it goes from 1.96 and goes up to 2.58. So therefore we say we're 99% confident that the true mean GPA is between 2.90 and 3.62. Okay, so now the last question I want to ask, stop the video as you go through this. Let's just say we take a random sample of 50 people and got a sample mean and got the same sample mean, the 3.263. Find a 95% confidence interval. So stop the video and figure out the confidence interval as well as interpret it. Okay, so this is how we calculated. The only difference between the first confidence interval we calculated and this last one is the sample size. So it goes from 24 to 50. And now we have a confidence interval between 3.07 and 3.45. So we are 95% confident that the true mean GPA is between 3.07 and 3.45. So the two questions I want to ask you is that what happens to the width of our confidence interval as our level of confidence goes up and as our sample size goes up? And think about it for just a sec. Okay, so if you compare these if we compare these confidence intervals, you find that the width of this confidence interval is wider than this one. So when our level of confidence goes up, the width of this confidence interval goes up. And as our sample size goes up, notice if you compare it between this confidence interval and this one, the width here is smaller than it is here. So when we summarize this, what happens to the width of the confidence interval as the level of confidence and the sample size increase? Well, as the level of confidence increases, the width of the confidence interval increases. And as our sample size increases, the width of the confidence interval decreases. So this concludes part one. We'll continue with part two with summarizing confidence intervals and sample size calculations.